Let's go ahead and work through some examples here so we can practice setting up and evaluating double integrals. So in the first example, we have that D is a triangular region, and it's formed by the 3 points 0, 0, 2, 2, so go ahead and plot that, and 3, 0. So I have these 3 points, I'll label my axes here, and those are going to form a triangle. So we'll go ahead and put in the edges of that triangle. Use lots of colors here. And then we'll keep the bottom one there as pink. So if I'm looking at this triangle, this is the domain of my integral. So I have some function. This function, 1 minus y squared, that doesn't come into play at all when we're drawing out the base. That's different than that domain region D. So what I've drawn here is just my domain region D. So this is my region D here. Okay, so we want to set up this double integral. So I have to decide if I want to do a type Y or a type X. When we do a type Y, we're going to move in the direction of that Y axis from the bottom to the top. And I notice as I do this, sometimes I go from this pink curve and I exit near the purple curve, pink, purple, pink, purple. But then I switch and I end up going from pink to green and pink to green. So I can't set that up as just a single integral. I would need 2 different integrals. So we'll see at the end how to do this as 2 different integrals in type Y. But I do notice if I do type X, then I can just do 1 integral, because if I move in the direction of the x-axis from left to right, I first hit into that purple curve and then I hit into this green curve. So let's set it up in sort of our basic idea. So I'm going to do a dx, an x first, so I can move in the direction of that x-axis. Again, I like to draw in my little arrows here. So we'll say we're moving in the direction of that x-axis. And as I do that, the first thing I hit is this purple curve. So that's going to be the lower bound, purple. And then the next thing I hit is this green bound. So we're going to go from the purple curve to the green curve. And because it's a dx integral, I need these to be x equals and x equals. Now, after we do that, we can think about projecting away that x-axis or getting rid of my x-axis there. So if I get rid of that x-axis, I'm just left with the y-axis. And I want to push everything back. So the purple line and the green line both get smushed into there. And those both end up here at y equals 2. And they start down here at y equals 0. So on the y-axis, I can see that I'm just going from y equals 0, and the highest thing is y equals 2. So my y bounds will be 0 and 2 there. Okay, we also have our function, 1 minus y squared. So now all we need to do is figure out what this purple curve is and what this green curve is. And once we have those equations in terms of x equals, we can actually evaluate this out. So let's do that over here. For this purple line, we know that's going to go from 0, 0 to the point 2, 2. So I have 2 points. I can find the slope, change in y over change in x. And now I can use point slope, y minus 0 equals 1, x minus 0, or y equals x. So this purple equation here has the equation y equals x. I'm doing an x first, dx integral, so I need x first. So I'm going to think of it as x equals y. So let's go ahead and just rewrite everything we have from above. And I just found out that that purple equation was x equals y, so I'll put the y down there. Now for the green one, we'll do that off to the side here. For the green one, that's a line that goes through 2, 2 and 3, 0. So my slope, change in y, -2, change in x, 1. So my slope is -2. And then my point that I know it goes through, let's use 3, 0. So y minus the y value equals -2, slope, times x minus the x value. So y equals -2x plus 6. So this line here is y equals -2x plus 6. But again, because I'm doing a dx integral, I have to have it as x equals. So I can solve for x. I get that y minus 6 equals -2x, or x is equal to -1/2 y, and I divide by -2, I get a plus 3. So the equation here becomes -1/2 y plus 3. And so it asked us to set up but not evaluate, so that's going to be my final answer. So the x here goes from x equals y, that was that purple line, to x equals -1/2 y plus 3, that was my green line. And after we do that, the points that y goes between are from 0 to 2. Okay, so we said we don't want to set this up as type y. It's not a type y integral because it would need more than one integral to set it up in terms of y. But why don't we go ahead and actually just see what that would look like. So I'm going to go and duplicate this slide. We'll get rid of our x work, and then we can see what's going to happen if we do a type y integral. So let's go ahead and do that. And we'll look at that in the next slide. Okay, so we have the same setup as we had before. I left all the equations of the lines in there. And we had said that this is not type y. Since it requires two integrals. Integrals in y first perspective. But even though it's not type y, we could still set it up with y first. We just have to use those two integrals. So let's actually see what that's going to look like. So I'm going to have to use two different integrals here. Both of them will be y first. Let's go ahead and do that setup. I'm just going to write the second one on the next line here so that we have space. And both of them will still have that function 1 minus y squared in there. Now, what are those two integrals going to be? So let me go ahead and just give us some space inside here to draw. And we're going to think about what happens if I go in that y direction now. So instead of going in this x first direction of that x-axis, I want to move in the direction of my y-axis. So I'm sort of thinking about moving in this direction here. And I noticed that the first curve I always hit is always this pink curve. So on both of these, I'm going to have that pink curve on the bottom. But sometimes I end up in the purple area, and other times I end up in the green area. So let's go ahead and just color code. I'll just color the green one green, and I'll color the purple one purple, depending on what their top is. And so in the purple region, I'm going to go from the pink curve to that purple curve. And in this green region, when I move in the direction of that y-axis, I go from pink to green. So those are the two different integrals we need. They both start at the pink curve for y. One goes up to purple, one goes up to green. And now we have to think about our x bounds. So if I look at it, x we know overall goes from x equals 0 all the way out here to x equals 3. But I'm going to switch from that purple region to that pink or that green region here at x equals 2. So the purple region, that only lasts from x equals 0 to x equals 2. while the green region goes from 2 to 3. So again, we can set this up as type y. It needs 2 integrals, so we don't call it type y, but it can be set up as a y first integral. If I want to actually finish this, though, I shouldn't just write pink and green and purple. I should actually put in those curves. So let's go ahead and finish that up. So I'll put in all of the pieces again. dy dx plus that second integral. Oops, put those constants in the wrong. Okay, let's go back a little bit here. Move those out of there. 1, come on, 1 minus y squared dy dx. And then we had those constants of 0 to 2 and then 2 to 3, depending if I was in the purple zone or I was in the green zone. The pink curve, again, this is y first. So the pink one should be written as y equals, oops, this pink curve though here is just y equals 0. So they both get a 0 on the bottom. And now the purple curve in terms of y equals is x. So I just put an x up there. And the green curve in terms of y equals is negative 2x plus 6. So I can put that in there. So then this would be my final answer if we actually have all of those functions plugged in. Let's, whoops. Okay, so I definitely encourage you for this one to go ahead and try it on your own first. You won't be able to enter your answer anywhere, but you can try it on your own and maybe fast forward to the end and see if you got the same thing that I got. But this one is a practice with switching the order of integration. So let's go ahead and do that. I always like to switch the order of integration by drawing out my region. So to start off, I have that x goes from 1/8 y squared to square root of y. Now, I like to draw curves in terms of y equals. So I'm going to take both of these and rewrite them. So I get y squared equals 8x, which is y is the square root of 8x, but it could be plus or minus. So I'm going to get that nice square root function, and it could be either the positive or the negative. Now on the other side here, I get x equals root y, so y is equal to x squared. So I'm going to get that nice parabola there. Let's find the intersection points between these two curves to make sure that we made a graph that makes sense. So I can do it either way. Maybe I want to do it here. They were both x equals. So I can set the y's equal because they were both equal to x to begin with. Square both sides. And then either y equals 0, or we can divide by y to get 1 over 64 y cubed equals 1, or y cubed equals 64. So y is going to be the cube root of 64, which is 4. So I get y is 4, plug that back in, x was equal to square root of y, so that means x equals 2. So this intersection point here occurs where x is 2 and y is 4. Okay, so those were my x bounds. X went from 1/8 y squared, that was the lower bound on x, to x equals root y, that's my upper bound on x. So my x region is the region in between those two curves. And then we had that y went from 0 to 4, so I am going to get this entire region. If y only went up to 3, I would be cutting it somewhere, but that's not what we're doing here. Okay, so now we want to switch this order. So before I had an x first perspective. Now I want to change it around and have a y first perspective. So if I'm moving in the direction of that y-axis, the first curve I hit is the blue curve, and the second one I hit is that purple curve. And I want to do y first, leave the function the way it is, and then after that I can do x. And I notice that x will just be in terms of constants, so it's the second, since it's the second one, so that's just from 0 to 2. Okay, so then I just need to find the blue and the green and the purple in terms of y equals. So for my blue curve, I have already that y equals x squared. So I can put that in. For the purple, we have that y equals the square root of 8x. I only needed the top half of that. That was the only one that came into play because I had y was always positive values. So just writing that out without the words blue and purple in there, our final answer would be the integral from 0 to 2, the integral from x squared to root 8x. The function stays in there. Now I've changed it so it's dy dx. So again, we took what they gave us, we changed that into these inequalities to find those curves, graphed those two curves, found the region that they were describing by finding the region in between them, and then once we had that region, we were able to view it from that y first perspective, so move in the direction of that y-axis, find the bottom curve, and find the top curve, and then we just found their equations in terms of y equals. Definitely go back, review these as much as you can, try to get all these ideas down. The best way to do it is to just keep practicing.